Let's take a look at another problem. Cars A and B cross the start line simultaneously, where each car maintains a normal acceleration of 0.8 g's in the turn. How much time passes from start to finish for each car? Which car won the race, and how far ahead is the winning car? Assume the track is level and that there are no speed changes during the race. To start, let us write out our assumptions and givens. We know that the normal acceleration for each car is 0.8 g's and that there are no speed changes throughout the race. How does this information help us, though? Well, if there are no speed changes throughout, the tangential velocity is constant for each car, which means that the tangential acceleration of each car is 0, since we know that the velocity vector is always tangent to the direction of motion. How can we introduce equations to acquire our time variable? Since we have information about our velocity, we might try to divide the velocity by the tangential acceleration to obtain units in time. However, since at is 0, this would yield an undefined time, so we must try a different approach. We have information about the normal acceleration, but since velocity is always tangent to the direction of motion, we do not have a normal velocity, so this approach will not work either. So, what other information do we have in this problem to help us calculate time? Well, since the track is level and traces a semicircle, we can acquire the distance traversed from the arc length equation, which yields s is equal to rho times pi. Therefore, if we divide our traversed distance s by the tangential velocity, we can obtain time. Now, all we gotta do is solve a little bit of math. In this example, SA equates to 282.74 meters and SB equates to 361.28 meters. As shown, car B travels further than car A, which makes sense because car B travels alongside the outer portion of the track. Next, to obtain the velocity, we can use our formula for the normal acceleration, which is v squared over rho. With a little bit of manipulation, we see that v is equal to the square root of 0.8 times rho g. Using this expression, we find that the velocity of car A is 26.58 meters per second and that the velocity of car B is 30.04 meters per second. Finally, we plug both values for each car into our expression to yield that the time to cross the finish line from the start line is 10.64 seconds for car A and 12.03 seconds for car B. So, as is shown here, car A won. Also, to clear up any confusion, R1 and R2 correspond to the center of each lane, respectively, which, as is shown, does not exactly match up with the picture. Since we know that car A won the race, we are almost done with this problem, but we have one part left, which is at the finish line, how much further ahead is car A relative to car B? Well, since we know our tangential acceleration is constant, we can utilize our familiar constant acceleration equations. The equation delta s is equal to v times t plus 1/2 a times t squared will in particular be used in this problem. It's important to note that since car A won, we will utilize car A's velocity for v. However, what should we use for the time variable? Well, since we are interested in the distance between the two cars, we ought to utilize the difference in times of the two cars to cross the finish line. Therefore, t in this equation is going to be tb minus ta. Noting again that at is 0 in this problem, so that second term will cancel out. We can then solve our expression to yield that car A is ahead of car B by approximately 36.95 meters. And that's it for this problem. I like this problem. It was a good introduction to the normal and tangential coordinate system, and I hope this video was helpful.